In this lecture, I will share how to derive a relation between electric field and electric potential. Both these things are related to each other by a relation. Now let's see how to derive this relation. For this purpose, let me consider a coordinate system, three-dimensional. Suppose it is x-axis, y-axis, and z-axis. Suppose at the origin there is point source charge plus q and a test charge is moved from point A to point B via any arbitrary path. Let me suppose a very small displacement on the path. Suppose this displacement of test charge plus q naught is dl vector, very small displacement, and this electric field at this point is E vector. Similarly, direction of Coulomb force will also be same because this is point test charge, this is point source charge. They will repel each other because both are taken positive. So E vector or F vector can be taken along this direction. Now what is small amount of work done? Small amount of work done during small displacement dl vector that I have assumed here. By definition of work, I can write dw equal to F vector dot dl vector. Now by definition of electric field, I can write E vector is equal to F vector divided by test charge. This will give us value of F vector as Q naught into E vector. If I put this value of F in the previous equation, I can write dw equal to Q naught E vector dot dl vector. In order to calculate total work done in moving from point A to point B, I will have to integrate this equation. So integrating this equation on both the sides, I can write integral dw is equal to q naught is constant, can be taken out of integration. Inside integration, I will write E vector dot dl vector. As we are moving the test charge from point A to point B, so integration will be taken with the lower limit as A and upper limit as B. Similarly, on left hand side, it is a limited integral. So left hand side will give you answer as W equal to Q naught integration E vector dot dl vector from A to B. And this work done is total work done in moving the test charge from point A to point B. Taking Q naught to left hand side, I can write equal to E vector dot dl vector A to B. By definition of potential difference, this is work done in moving the test charge from A to B. I can denote it by WAB. WAB upon Q naught is nothing but potential difference between points A and B equal to E vector dot dl vector A to B. So this is the required relation between potential difference and electric field. So we can say potential difference between 2 points is equal to line integral of electric field between the same 2 points A and B. This is the relation between electric field and electric potential difference. That's all.